Hi, this is chih-chien and this is the demo for lab4. So let us look at the RC file here. We have reset, we have clock, we have D in, D out, and this encryption flag indicates whether this is encryption or decryption. Then let's look at, okay, so for this array, these are just values for doing encryption and decryption, right? Constant values. And okay, let's look at the process here. So when the reset equals to 1, we're resetting the I equals to 1 if we're doing encryption. And we reset I equals to 12 when we are doing decryption because, for decryption, it's just going down. Like, it's doing backwards. So after, just doing backwards. So, and then here we just assign, A and B values by the D in, okay? And for positive clock age, right? For positive clock age, we increase the value of I by 1, and we decrease the value of I by -1 if we're doing, decryption, which encryption flag equals to 0. And then here we just, set, we have this, upper bound and lower bound just to make sure that we don't blow up the array, right? We don't access the array that does not have any elements. Then basically it's an out of bound problem. And then here we just assign different, output to A and B for the next run, operation, and it's different. It's different because one is encryption, the other is decryption, and we can see that clearly down here, right? We have like these two, we have different output signal like A out, B out, and we have B decryption out, we have A decryption out, and these is just simple because we first add and then we rotate, and then we have this A out value, and then and we use this A out value to encrypt the B. Same thing happens here, just reversely. We have minus, and then we have this B decryption out, and we use B decryption out to decrypt the A value. Okay, let's look at the task bench. So task bench here, we just assign, reset and all this value after, encryption. We do the decryption so that we can look at the task bench simulation result, right? First, we have this, value, and then this is the first encrypted value, and then we do the encryption, and we can see that we have this encrypted value here, and then we just do decryption again, right? And then it gives us back the original value, which is successful. Okay, let me look at the FPGA. So FPGA, we have switch buttons, these for 7-segment display, and we have a clock. And here we just, nothing special, slow down clock for encryption and decryption so that we can see each run, right? Like each clock cycle, it does one round of operation, and then we can see the result after that operation. So if we use slow down clock, and so then we can clearly see the result, right? The process result. And then for 7-segment display, one thing special here is that I put switch 2 as a select value, because here we have D out equals to 64 bits, and 7-segment plays can display only 32 bits at a time. So when it's equals to 0, it displays the first 32 bits, and then when A equals to 1, it displays another 32 bits. Then so that it can display total 64 bits of the out. And Here, you know, switch 0 is just reset, switch 1 is the encryption flag, and then we assign, you know, this original value and this encrypted value to decryption, and that's all the design. Thank you.